Hello, in this collab, I'm going to give a walkthrough of pytorch neural network tutorial notebook. And in the first cell, what I do is I import all the required libraries just as required for the further execution. And then in the next cell, which demonstrates all the common way to create a pytorch tensors from Python list and NumPy arrays and use built-in construction like zeros, ones, random, and I. Next, here I list all common PyTorch's D types, which we can see here: float 32, float 64, float 16, and all the things which we see here, and explain when each is used in deep learning. Next, in this cell shows how to check if CUDA is available, creates tensor on specific devices, and move tensor between CPU and GPU using two method. Next cell, I demonstrate all the core tensor operations, element-wise arithmetic, matrix multiplication with the add operator, and comparison operations. I also show in place operations with the underscore suffix. Next cell, this cell covers all the tensor reshaping methods: reshape, permute, squeeze, and unsqueeze. And in the next cell, this cell covers a answer for dot product, outer product, element wise multiplication, and matrix multiplication. Next is here I use, yeah, next here I use answer for batch matrix multiplication using the notation like BIG, BJK, and BIK. All these which we can see where B is the batch dimension. In the next cell, this cell prints a complete reference table of INSUM notation alongside their equivalent PyTorch operations. Next cell, this cell introduces PyTorch automation differentiation system by creating a tensor with the required grad equal to true, performing operations and calling backward to compute gradients. Next, here I build a multi-step computation graph by chaining operations across multiple tensors and then call backward to trace gradients back through every operation. Next cell, this cell computes gradients for vector input by computing the sum of squares and calling backward. Next, here I demonstrate three critical autograd patterns: gradient accumulation that happens by default and requires zero grad between steps, stopping gradient flow with torch no grad during interference. Next, this cell implements manual gradient descent to minimize a simple parabolic function and plots the optimization path. And in the next cell, I re-implement the four main activation functions: sigmoid, tanh, ReLU, and leaky ReLU, using only basic PyTorch tensor operation and no NN module. Next, this cell implements MSE loss for regression and binary cross entropy loss for classification. Next cell, here I build a complete neural network class using only raw PyTorch tensor and autograde to NN.module and NN linear no optimizer classes. Next, this cell trains the primitive network on the SOR problem, which requires a nonlinear decision boundary. Next, here I introduce NN.linear as PyTorch built-in fully connected layer and inspects its automatically created weight and bias parameters. Next cell defines a simple net class by inheriting from NN module and implementing the forward method. After that, I build a multi-layer networking using a NN.sequential which chains layers in order and automatically passes the output of each layer as the input to the next. Next, what we do is define a production-ready neural network class on NN module that accepts any list of layer size and activation functions and dynamically builds the architecture. Next, here I create an instances of all major PyTorch optimizers like SGD with momentum, Adam, and RMS prop, and primdoor hyperparameters. Then next cell, this cell defines a reusable train models functions that handle the full training loop, batching data with data loader, forward pass, loss computation, backward pass, and optimizer step and gradient zeroing. Next, here I solve a XOR problem using the high-level NN sequential API instead of primitives. Next cell generates the two moons dataset using PyTorch tensor, build a multi-layer classifier, trains it, and plots the learned decision boundary. Next is, here I load a sklearn digits dataset of 8 cross rod handwritten digit images, preprocess it with standard scaling, convert to PyTorch tensors, and train a multi-class classifier with 10 output neurons. Next, in this cell, This cell displays a 3x5 grid of test digit images with the predicted and true levels, coloring correct predictions green and mistake red. Next is here I print a side-by-side comparison table of three approaches used in the notebook: NumPy from scratch, pytorch, primitives, and nn modules. In the last cell, what we do is final cell prints a comprehensive pytorch cheat sheet covering tensor creating, reshaping, autograd patterns, the standard training loop structure, and common layer types. That's it with this notebook. Thank you.